Welcome everyone to my video on maximum and minimum of functions of a single variable. I'm R. Jennifer Rose, Assistant Professor in the Department of Mathematics, RMD Engineering College. The insight of this video are introduction, formal definitions, graphical representation, and applications. One of the most important applications of differential calculus is the optimization problems in which we are required to find the optimal way of doing something. We learn how derivatives affect the shape of a graph of a function and how they help us locate the maximum and minimum values of a function. We will now look into the formal definition of maxima and minima. They are of two kinds, absolute or global maxima or minima, local or relative maxima or minima. Absolute maxima. A function f has an absolute maximum at a point c if f of c is greater than or equal to f of x for all x in the domain D of f. The number f of c is called the maximum value of f on D. That is, in the entire domain of the function, the largest value of f gives the absolute maximum. Next, absolute minima. A function f has an absolute minimum at a point c if f of c is less than or equal to f of x for all x in the domain D of f. The number f of c is called the minimum value of f on D. That is, in the entire domain of the function, the smallest value of f gives the absolute minimum. Now the definition of local maxima. A function f has a local maximum at a point c if f of c is greater than or equal to f of x when x is near c. That is, f of c is greater than or equal to f of x for all x in some open interval containing c. Local minima. A function f has a local minimum at a point c if f of c is less than or equal to f of x when x is near c. That is, f of c is less than or equal to f of x for all x in some open interval containing c. Let us understand the definitions of maxima and minima with a graphical representation. It is clear from the graph that the highest point occurs at x4, and so the corresponding value at the point x4 is f of x4. We say that the absolute maximum occurs at x4. Similarly, the lowest point on the graph is at x1. The corresponding function value is f of x1. And so we say that the absolute minimum occurs at x1. If we consider the values of x near x2, that is, in the interval open interval x1, x3, then f of x2 is the largest of those values of f of x and is called the local maximum. Likewise, f of x3 is called a local minimum in the interval x2, x4. Having understood the concept of maximum and minimum, let us try to locate where maxima or minima occur. They occur at the number c where either f dash of c equal to 0 or f dash of c does not exist. They are given a special name called critical numbers. So, a critical number is a number in the domain of a function f such that either f dash of c is 0 or f dash of c does not exist. We can conclude that if a function f has a local maximum or minimum at c, then c is a critical number of f. Finally, we will look into the applications of optimization problems with few examples. As the first example, we have the problem of finding the shape of an object that minimizes the manufacturing costs. Secondly, we have the problem of finding the maximum acceleration of a space shuttle. Lastly, finding the minimum material required to make a particular object. In my next video, I will explain the methods of finding maximum and minimum of functions of a single variable. Thanks for watching.